Hey, Saxon Math, Course 3, Week 1, Lessons 1 through 4. Let's begin now with Lesson 1. We're going to talk about number lines and we're going to compare ordering integers. And hopefully we know what a number line looks like. A number line has a positive side and a negative side with 0 in the center. We're counting 1, 2, 3, 4, and it continues on, hence the arrow. And then we're going to count in the negative direction, negative 1, negative 2, negative 3, and negative 4. We recognize that all the numbers are greater as we move to the right. So let's go ahead and use this information to answer example 1. It says arrange these integers in order from least to greatest. And so each of these are whole numbers, positive and negative, and we recognize that they're integers. And if we organize them from least to greatest, we're going to start off with negative 3 because that's the furthest one to the left. Then we'll get 0, 1, and 3. And so we've organized them from least to greatest. Next, we're going to do a comparison. And when we compare, what we're going to do is determine whether one part is greater than, less than, or equal to. So we want to keep in mind that when we use this symbol, opening over to the right, we're saying that something over here is greater than whatever's on the right side of this symbol. And if we see this symbol, we want to recognize that something on the left side, I think I said it wrong last time, something on the left side is smaller or is less than something on the right side. An equal sign means that, they're equal. A couple things we want to remember. We talked about at one time the idea of absolute value. Absolute value refers to the distance from 0. So this basically says what is the absolute value of negative 3, or how far is negative 3 from 0. And hopefully, even without a number line, you recognize that negative 3 is 3 steps away from 0. So the answer, or the way I could rewrite this, is 3. And we want to know if 3 is greater than, less than, or equal to absolute value of negative 1, which is 1. Okay, keep that in mind. Sometimes I like to call the absolute value symbol the positive maker because it makes everything positive. Now that we've broken down these problems a little bit, let's answer the first one. What is the value that we would put between a negative 3 and a negative 1? Recognizing that negative 3 is smaller than or is less than negative 1, we would put this symbol. Recognizing over here that when we account for the fact that the absolute value signs essentially make the number positive, we recognize that 3 is greater than 1. And so we'd fill in that blank with this symbol. Here in example 3, we are asked to graph the numbers in the sequence on a number line. Recognizing what a number line looks like, we can just take a regular old number line and then we're going to plot points on that number line. So here I've done my best to make a neat number line so that I could have all of the numbers spaced out evenly. I did my best. And so what we're going to do is we're going to plot the numbers that are represented here. So the first one is negative 3, negative 1, positive 1, and 3. That's not it though. If you notice that there are 3 ellipses on either side, it says, and continue on doing that. And so what we have to do is now see, what are they talking about? What numbers are we choosing? Looks like every other number, looks like odd numbers, negative and positive. So I would also continue to choose 5 and negative 5, and I'd continue on. I'm going to highlight the arrow. That means continue on doing that. Let's look at example 4. It says graph 2 numbers that are 4 units from 0. So if we're going to graph it, we're going to need our number line. Okay, so we have our number line and we notice that we're going all the way up to positive 10, back to negative 10. We're supposed to graph 2 numbers that are 4 units from 0. And so we're going to go 1, 2, 3, 4. And that would be positive 4. I think you probably knew that. And then we're going to go back in the other directions. 1, 2, 3, 4. And there's the other number, negative 4. So we've graphed those two by putting dots there. Got a positive 4 and a negative 4. And we recognize that these two numbers, it makes sense for negative 4 absolute value to equal positive 4 absolute value to equal just 4, because that's how many spaces are between these numbers and 0. So you know what I want you to do? I want you to get all of the practice set done. I want you to do the other portion of the practice on your own. You do only the part that I gave you to do. And if you want to check these, I'd like you to go to Quizlet, and you can find your textbook. This isn't yours, but let me see if I can grab your textbook. You can search for your textbook. You'll find this picture of the violin. You'll click on it, and you will now have access to 4,042 solutions to everything that you've been doing. So you can go to the first section, which is a chunk of the lessons, section 1 or chapter 1. When you click on it, you can see answers to all of the exercises. Each of the sections are the lessons, so you can go to section 1 and exercise 1, and you can get the answers to all of those problems. So make sure you check your work. You are responsible for that. The answers are provided here with limited explanation. Do the best you can. And I look forward to seeing you on the next lesson, which is lesson 2. Take care. All right, so here we are with lesson 2. We're going to be talking about operations of arithmetic. And so we have a couple of examples. But before we do that, let's kind of think about what these operations are. The 4 basic operations are going to be addition, subtraction, multiplication, and division. And one thing we need to be really aware of is when we're asked questions and we're supposed to define or figure out what operation we need. So a couple of words I want you to keep in mind. I want you to keep in mind when we're talking about addition and we're looking for the answer, we're going to use the word sum. That's exclusive to addition. I'm never going to ask you for the sum of a multiplication problem because sum really means to add. Subtraction, there's a lot of words. It could be difference, how much more than. Difference. The difference, how much more than we could use. Multiplication, we use product. The answer to a multiplication problem is the product, and the answer to a division problem is the quotient. And so I want you to be aware of these words when we're doing operations of arithmetic. These are some of the language that you'll see. With that in mind, let's go ahead and look at our first example. The first example says, what is the quotient when the product of 3 and 6 is divided by the sum of 3 and 6? What? So let's go ahead and take our time and think about that. What is the quotient? So we know there's going to be some division happening. And they talk about dividing. What is the quotient when the product of 3 and 6? Well, I know that this business here, this product of 3 and 6, that's going to be the answer I get when I multiply them. So I know low-key that's 18, all right? So what is the quotient when 18 is divided by the sum? Sum is the answer I get when I add. So the sum, let's use a different color here, the sum of 3 and 6, well, I could replace that phrase with 9 because that's what I get when I add 3 and 6. You guys with me? I hope so. Okay, so now I've got what is the quotient when 18 is divided by 9? Oh, that's not too bad. So of course I could write 18 divided by 9 like this, or I could write 18 divided by 9 like this, or I could write 18 divided by 9. Each of these, no matter how I write it, is going to be 2. All right, so that's the first one. Let's look at example 2. Example 2 has us doing a simplify and check. So we're going to do some basic arithmetic. We're going to be subtracting and we're going to check it. So when you check subtraction problems like we have this one, you do it by doing the opposite. You will add the answer or the difference plus the subtrahend, this one that we're taking away, to get the minuend, the one that we got. Ooh, I hope I got those words right. All right, you'll see what I mean right now. So I'm going to subtract these guys. I got to do some borrowing. I can't just do 6 minus 7. So I go next door. 0 says I ain't got nothing. So I got to go next door again. And 7 says I'll lend you some. Lend some to 0. 0 becomes a 10. 10 says I got you. Becomes a 9. While it gives us a 1 here to make a 16, or really a 10 to make a 16. So 16 minus 7 gives us 9. 9 minus 2 gives us 7. And 6 minus 3 gives us 3. So 379, not that big a deal. However, the check part is when we take the 379, which is our answer, and we take the number that we subtracted and we add it together to check. I know it's boring, but let's do it anyway. 9 and 7 is 16. 6 down there, carry your 1. 7 plus 1 plus 2 more is 10. And we carry our 1, and then we have 3 plus 1, which is 7. And we now can feel satisfied because we ended up with the things that we started with. So we check that. Let's go ahead and do this long division. Well, I'm going to do it as long division. 25 is the divisor, and the dividend is 450. And we're going to divide 25 into 450. So 25 goes into 45. Can't go into 4, but it can go into 45 one time. When I multiply 1 times 25, I get 25. Subtract, I get 20, and I'm going to drop my 0. Can 25 go into 200? You betcha. And it goes in there 8 times. 8 times 25 is 200, and I'm done. So now I can write 18 here, but we got to check it. How do we check it? We check it by doing the opposite. Here, when we were subtracting, we needed addition to check. Here, when we're dividing, we need multiplication to check. So what I'm hoping is if I take 25 and I multiply it by 18, I'm going to get 450. Let's try it out. 8 times 5 is 40. 8 times 2 is 16, plus 4 more is 20. I'm going to now move over to the 1. 1 times 5, really that's a 10 times 5. That's why we put the 0 here to move it over. 10 times 5 is 50. And then 10 times 20 is 200. That's where we got that 250 from. All right. So what is happening? Dun, 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 dun. We got the right answer. It's the same thing. We were impressed with ourselves. So that's how we simplify, do the math, and then check it by doing the opposite operation. I'm going to erase some of this so we can see this chart a little better. So as we look at this chart, we have a couple of properties that you may want to spend some time looking at, and I will talk to you about these. Okay, I know this is not fascinating stuff, and I know some of it you're like, I already know it, but mathematically, we like to get the terminology right. And so mathematicians have lots of concepts that we like to name and be clear about. So the first concept we're going to talk about is the commutative property of addition. When I think about the word commute, I think about going to a job, going to a place, going from one place to another, moving around. And so the commutative property of addition says you can move around the numbers and add them in any order, and they will still be equal. The commutative property of multiplication says the same thing. A times B, B times A, same thing. You can move them around. They can commute. They can move. So that's the commutative property of multiplication and the commutative property of addition. What about the associative property? So these associative properties, we're focusing on these now. These associative properties basically say that they can associate in any grouping. As long as you're adding things together, if you associate 2, meaning you add 2 together and then add the third one, if you change the order of your adding, if you added these 2 together first and then added the first one, you're going to get the same answer. So it doesn't matter how you do it or the order in which you associate these guys together, you're going to get an equivalent value. So the association property of addition says doesn't matter how you organize, doesn't matter how you group them. And so that happens over here as well with multiplication. You can group these guys together first, or you can multiply these guys together first and then multiply the other number. Doesn't matter. It's still going to be the same value. Now we have the identity property of addition and the identity property of multiplication. When I think of identity, I think about looking in the mirror and I think about seeing myself. And so when I have identity property in addition, it's basically I'm going to start off with my number, perform an operation, and I'm going to get that same number back. A plus 0 equals A, meaning anything plus 0 is that same number. 3 plus 0 is 3 is just an example of that, all right? And similarly, we can talk about seeing our identity here. A times 1 is equal to A. Just like 3 times 1 is equal to 3. We get the same thing out when we multiply. And the final one that we'll talk about, this is called the zero multiplication property. It's kind of a neat thing because it doesn't matter what you multiply by 0, you're always going to get 0. So any old number, a times 0 is equal to 0, and the example is 3 is equal to 0. So I know that was kind of like, yeah, and, well, a lot of textbooks like this one will ask you to like solve a problem and justify your steps with these concepts above. I'm not a fan of it, but I understand it has its place and it's something you want to know how to do. It does make mathematics clear as to why what you're doing is legal. However, I understand that sometimes it can be frustrating. Let's do example 3. Okie dokie. So when I look at this problem, multiplying big numbers, I kind of don't feel like it, but I see some cool things. I'm looking, I'm saying, oh, wait a minute. If only I could move some stuff around. I'd like to multiply 25 times 4, and then I can do some things a little bit differently. So the first thing I'm going to do is do this. I'm going to put the 4 over here, and I'm going to put the 25 times 15 here. This is actually the commutative property because I move things around. The next thing I'm going to do is say, okay, let me multiply my 4 times my 25 first, and then I'll multiply by 15. Now that's the associative property. I associated a different pair of numbers, and I know I'm still talking about the same thing. So this is equal to this, and this is equal to this. Everything I'm doing is going to be equal. Now, 4 times 25 is easy. It's like having 4 quarters, which is 100, right? Having 4 quarters is $1, which is 100 cents. So I know that's good to go. And that's just me multiplying 4 times 25. And then finally, multiplying 100 times anything is a cinch because I'm just going to add the zeros at the end. And so now I get 1,500 or 1,500 by multiplying. Do you see the process? So this is the type of stuff that your textbook is asking you to do. I want to talk about this with you. We'll talk about it. I want you to understand the terminology, but I'm not pressed if when you're doing problems, you don't actually go through and write down all of this information, because I think sometimes it is onerous. I'm more impressed if you can understand how to work the problem, and we can talk about justifying later. All right, so this next one, we've got to simplify this. 100 minus 365. And I don't remember how much negative positive numbers we talked about, but here's the deal. If I have 100 and I'm going backward on, let's say, the number line, and I'm thinking about going backward to 365, going backward 365 steps. Here's 100. Here's like 0. So if I go back 100 steps, I'm at 0, right? But I've got to go back 365 steps. So that means I got to go back more. In fact, I've got to go back the difference between 365 and 100. So one way to calculate this is to recognize, whoa, I'm subtracting a big number from a little number. My answer is definitely going to be negative. I'm going to be in the negative realm. If I went back 100 steps, right? If I went back 100 steps, I'd be at 0, but I've got to go back even more to get to this number. What would that number be? Well, that number would be negative 365 minus 100, because I've already gotten to 100 steps. I'd have another set of steps to go. What would that be? Well, that would be 365 minus 100 is 265. So I'd have 206. I'd be all the way back here at negative 265. So I'd be all the way back there because I'd take another negative 265 steps or steps in that direction. And so I know that the answer to this is negative 265. I hope that made sense. All right, we can talk about it again if it didn't. Here we're going to have some fun. We're doing a little bit of algebra. We are trying to figure out what is the missing number. Find the value of x and y in the equations below. So 6 plus x is equal to 30. If 6 plus a number is equal to 30, then what I know is 30 minus 6 is equal to that number that I'm looking for. Pause me and think about it. If you need it to make sense, even do some examples. Be like, oh, 2 plus 3 is 5. Is 5 minus 2 3? Oh, it is. Is 5 minus 3 2? Indeed. So if you can kind of work around with a thought that's a little bit simpler, sometimes it makes these make sense a little bit more. So now I know that I'm going to take 30, subtract 6 to get x. I'm kind of doing the opposite here. 30 minus 6 is 24. And that's exactly what x is equal to. 24 plus 6 would definitely give me 30. Over here, we've got 6y equals 30. And really, we know that this means 6 times y equals 30. But we're kind of big time. We're doing algebra with the letters. We don't want to do that. So we could do 6 dot y equals 30. Because like the letters are confusing. Like if I had an x, is that x? Is that multiply? Who knows? Too confusing. That's why we don't write it like that. So 6y means multiply. You could do 6 dot y if you wanted to. You got choices. But the key here is to recognize that if I have two numbers that multiply to give me another number, two numbers that multiply to give me a product, if I take that product and I divide by one of the factors, I should get the other. So 30 divided by 6 will give me y. It'll give me the value that I multiply to get 30 when I have 6. And obviously that number is 5. All right, so we did it. We've gotten through another lesson and you have a practice set to complete, all of them. I want you to get all of these done, and then I want you to do the other part of the assignment, which we talked about, and I assigned a certain portion. Get those done and then come back and check out what's going on in lesson 3. All right, talk to you soon. Bye-bye. Here we are, lesson 3, and we're going to be talking about addition and subtraction word problems. So this is where some of that language we talked about in lesson 2 is really going to help us in terms of sum, difference, quotient, product. So we want to make sure we understand what's happening. So the first half of the game, Heidi scored 12 points. In the whole game, she scored 27 points. How many points did Heidi score in the second half? All right, I like this problem. I'm going to think about this algebraically. First half, she scored 12. The second half, we don't know. But we know by the end, she scored 27. So this represents the first half. This represents the second half, P. How much did she score during the second half? And so we're going to solve it like we solved our equations from the last exercise or from the last lesson, where we say, hey, if two numbers add up to another number, we know that if we take one of these numbers away, we will get the missing value. And so we're going to take 27 and subtract 12. And when we do that, we realize that Heidi, the number of points she scored in the half, that was 15 points. All right, so here's our next example, example 2. Alberto went to the store with a $20 bill. He bought a loaf of bread and a half gallon of milk. The clerk gave him $15.17 in change. How much money did Alberto spend on bread and milk? Explain why your answer is reasonable. Okay, so we know we've got $20. We know that whatever he bought, the bread and milk, I'll put that here, bread and milk, the cost of that, right? If we subtract that, he got $15.17 as change. And so how can we figure out what is the cost of this? Well, this clearly looks like a 20 minus C cost is equal to 15.17. This looks like one of those algebraic problems that we've been just working on. And so what I would do here is take the 20 and subtract the change to see what the cost is. And so when I do that, lining everything up, I'm going to end up getting $4.83 for bread and milk. My goodness, I wish that were the case nowadays. All right, so $4.83. How can we be sure? Explain why your answer is reasonable. Well, couple ways you can explain it, because that's the math we did. We could also do a little bit of a check here where I take the change and my proposed cost, we add it up, and hopefully we get the $20 back. 7 plus 3 is 10. Carrier 1, 8 and 2 is 10 again. Carrier 1, 5 and 1 and 4 is going to give me 10. Carry one more and we get 20. So we can feel confident about our answer in that way. Here in example 3, we're looking at a hike to the summit of Mount Whitney, which began from the upper trailhead at 8,365 feet. The elevation of Mount Whitney's summit is 14,496 feet. Which equation shows how to find the elevation gain from the trailhead to the summit? So let's think about what we just read. So our situation is something like this. Let's pretend this is Mount Whitney, and we know that the elevation of the summit, the tippy top of it, is going to be 14,496 feet. We recognize that the hike started somewhere not at the very bottom, not at ground zero, but they found a place, maybe a path that led to around right here, 8,365 feet. So which of the following equations, now that we kind of understand the problem, let's look at the equations to see which one would give us what we're looking for, which is the amount of ground, or the amount of the elevation gain that we got by starting here. So let's see. All right, so looking at this equation here, we see that we've got 8,000. The 8,000 number plus G is going to give us 14,000. Does that look like it represents our situation? Could this be the gain, right? Or we could think about it as adding these two together. Would that equal the gain? That's what B is suggesting. For C, it says, hey, take the gain, subtract the greatest amount, and you'll get this. That doesn't make sense. This is small, this is large, and we won't get a positive number if we subtracted that. And finally, D says, take this 8,000 some feet, subtract the G, and we will get this taller amount. Again, this isn't making sense either. So given the situation, it looks like A is the best answer. Before we get to our practice set, let's take a look at this last example. President John F. Kennedy was elected in 1960 at the age of 43. In what year was he born? Well, if he was 43 in 1960, and we know he was born 43 years prior to that, subtraction is the name of the game here. So we'll do our old school borrowing. We've got a 7 here. 5 becomes a 5. We have 1, and we have a 9, and we have a 1. So it looks like he was born in the year 1917. So with that, we are at the end of this lesson. We're going to look to make sure we do all of our practice problems. This is going to firm up the concepts that we talked about here. Check them, use Quizlet to check them, do your assignment where you do the review problems as well, and then we're going to go on to the next lesson. Okay, so here is the next lesson. We're looking at lesson 4, multiplication and division word problem. So before we were doing with addition and subtraction, now we got some multiplication and division. Let's check it out. In the auditorium, the chairs were arranged in rows of 15 in each row. If there are 360 chairs, how many rows of chairs are there? Pause me, read it for yourself, think about it, and let's consider it together. Okay, so we're in an auditorium. We've got 15 rows of chairs, but we don't know how many chairs are in each row. Oh, wait a minute. An auditorium are arranged in rows with 15 chairs. So we've got 15 chairs in this one, 15 chairs in this one, 15 chairs in this one. Got a bunch of these, right? All the way until we get to the 15. These 3 dots just means we got something going on here. I don't know how many. So if there's 360 all together, 360 chairs all together, we need to figure out how many rows there are. Well, if I'm putting them in groups of 15, basically, I'm dividing 360 by 15. Do you see that? So if I divide that, the quotient, the answer I get here is going to give me the number of rows. So 15 can't go into 3, but it can go into 36. It goes in 2 times. And then when I multiply 2 times 15, I get 30. Rocking it out, subtracting that, I get 60 here. And now after I bring down my 0, and now 15 goes into 60, it can do that 4 times. So 4 times that gives me 60, and I'm done. And so what this tells me is that there are 24 rows in the auditorium. Let's look at example 2. The total cost for 5 student tickets to the country fair was $28.75. The cost of each ticket can be found in which of these ways? So 5 student tickets cost this amount. 5 tickets. I don't know how much the tickets cost, but 5 tickets. Let me write it like that. I don't know how much they cost each, but altogether they cost $28.75. Which one of these equations looks most like that? So 5 times the number of tickets, or the cost of the tickets, is equal to $28.75. That looks so much like what we have here. Let me look at the other ones. Would I take 28 and multiply $28.75 and multiply that by the number, by the cost of the ticket? That doesn't make sense. And I'm getting 5. That's very weird. How about taking the cost of the ticket and dividing it by 28.75? Would I get 5? How about taking the ticket cost and dividing that by 5? That doesn't even make sense. I wouldn't divide one ticket by 5. So 5 times the cost of a ticket, that's what T is representing here, would be $28.75. So A is the most likely candidate. That's one that we're gonna choose. Here's example 3. We've got Corey, and he's sorting quarters into groups of 40 so that he could put them in rolls. He has 375 of these quarters, by the way. How many rolls can Corey fill with the quarters? Explain why your answer is reasonable. I just need to see that if we're going to put them in groups of 40, that means we're literally dividing them by 40. So 40 cannot go into 3, 40 cannot go into 37 rather, but 40 can go into 375. But the thing is, I don't know how many times. So when I have a problem like this, I really do come over to the side and I will do just some little multiplication. So I know what 40 times 1 is, 40 times 2. This doesn't get to 40 times 10. That would be too high. So I'm going to go with 40 times 9. I'm just guessing. I'm trying to see if I can find a number that comes close to 375 but doesn't go over it. 40 times 10 would go over it because that's 100. 40 times 9 is 360, and that's exactly where I want to be. Just under 375, as close to as I can be. So I know I'm going to get 9 times 40 gives me that 360. Subtract, I get 15. And since I'm talking about like quarters and real things, I'm not really going to go for the decimal answer because it doesn't make much sense. Here, this 9, this quotient means that he will fill 9 rolls with his 40 quarters per roll, and he'll have 15 left over. So this is a great place to use remainder 15 and not go all like decimal or fraction crazy. So how do I know that this is true? Because I know 9 times 40 gives me 360, and I can see the 15 that would be left over. Our answer seems reasonable because I said so. No, it seems reasonable because we reasoned correctly in terms of multiplying and dividing and getting our answer. It makes sense that if we started off with 375 quarters and we're putting them into these groups of 40, that we're going to have close to 10. So after thinking through the problem, I feel confident about it and I'm ready to go on to our practice set. So you got a practice set. This is a nice short one though, right? This one isn't too bad. So we have a little practice set. You must do it. Check your answers on Quizlet and then do the assigned problems from the following practice assignment. And after you do that, you've done all the lessons all the lessons that are expected of you for the week. That's 1, 2, 3, and 4, and you're good to go. With that in mind, I'm going to let you go and look forward to talking to you soon. Let me know if you have any questions or problems and we'll straighten them out. Take care.